This video is going to show you how to do the problems on page 131 out of your math book. Bobby draws a square that is 10 units by 10 units. He increases the length by x units and the width by 2 units. Draw a diagram that models this scenario. So we're going to just start with really what they gave us. There's a square and it's 10 by 10, okay? And I'm going to try my best to draw a square. So as you know, squares, they have equal side lengths. And they have 4 right angles. And this length and this length are parallel to each other, and this length are parallel to each other. Okay, so there's my square. And I'm going to label it. It was 10 units by 10 units. Okay. And it didn't tell me the specific units, but I'm just going to, it's not inches or centimeters or anything, so I'm just going to label it with just a 10. And it's saying that he wants to increase the length by x units. So right here, I don't know how big x is, so you know, it's a variable we don't know. So I'm just going to go this way, x units. Okay? And then he wants to increase the width by 2 units. So up here, I'm going to go 2 more units. And he's expanding it that way. So now I'm going to go ahead and enclose. Hopefully it still kind of has straight lines. Now x and 2, they're not the same. Otherwise we would have that x equaling 2. We don't know how long x is. So you know, it could be like a little bit longer than that. Okay, so from here to here it's x. From here to here it's 2. Okay, so I'm going to go ahead and just kind of divide this up into little boxes. Alright, so the distance from here to here, that's 10 units. Distance from here to here, or here to here, it's 2 units. And then the distance from here to here, that's 10 units. From here to here, it's x units. From here to here, it's x units. From here to here, it's x units. Okay? So to better model this, I want to go ahead and show you what the area would be. How many square units compose this shape right here. So I know this is right here a 10 by 10. So 10 units by 10 units would give me 100 units squared. Okay. And then this one right here, this little part, it is 2 times 10, which is 20 units squared. Then this right here, length times width, because you know it's like a rectangle, it's 2 times x, so 2x units squared. And then from here to here is 10 units, and from here to here is x units, so that's going to be 10x units squared. Okay? So the original area was just 100 units, but remember how this Bobby guy expanded it? So now the new area, we just add all those areas together, it would be 100 plus 20, excuse me, plus 2x plus 10x. And combine like terms to simplify, so we have right here 120 plus, well, we can't add this to that because those are not like terms with these constants. So the simplest we can get this area would be 2x plus 10x, which is 12x. This amount right here, units squared, is the new area. Okay? And the old area was just this right here, 10 by 10. 10 units by 10 units, length times width, which was 100 units squared. Okay, now for the next one. Assume the area of the large rectangle is 156 units squared. Find the value of x. Okay, so now they're saying the area of the large rectangle is 156 units squared. So this whole entire thing, they're telling you, hey, there's 156 square units that make this. Find the value of x. So we gotta figure out, well, then what's x? So to figure that out, you know, to get that new area, this, we gotta set it equal to 156. So let me go ahead and demonstrate that, okay? So when we go when we add these little areas together to get the full area of the whole entire thing, it should equal 156. So 100 plus 20 plus 2x plus 10x. That's where we stopped before because we didn't know that what the area would equal. But now we know, so I can add the equal sign and say, hey, it's 156 units squared. So from there, now you can solve for x. Well, kind of. You got to build it first after you simplify it, okay? So combine our like terms. Here's some constants, 100 and a plus 20. That's 120, positive 120. And then I see I got a positive 2x and a positive 10x, which is a positive 12x. Okay? And then bring down your equal sign, bring down your 156. Now you can build it if you need to. Start with x, multiply it by a positive 12 because it's positive, times 12. And then we just added 120. Inverse operation of adding 120 is to subtract 120, so that's what you can do to both sides of that equal sign. 120 minus 120 is 0. 156 minus 120 is 36. Bring down your equal sign, bring down your positive 12x. Okay, go back up. Inverse operation to multiply is to divide. Do that to both sides of the equal sign. 12 divided by 12 is 1. 1 times x is 1x, or x. 36 divided by 12 is 3, okay? So that value of x is 3. So this person, this Bobby guy, expanded it out by 3 units, okay? And that, when I substitute that 3 in for the value of x, I would get 156. So let me go ahead and just show you that, okay? So I gotta put a 3 right here. There's another, put a 3 right there. Even up here, put a 3 right there and put a 3 right there, okay? So 100 plus 20 is 120. Plus, what's 2 times 3? Well, that's 6. Plus, what's 10 times 3? That's 30. Hey, didn't they tell us that? Okay, and it'll also work right here in this equation. This side has to equal this side for an equation to be true. So 100 plus 20 is 120. Plus 2 times 3 is 6. And, you know, positive 10 times 3 is 30. So that's what added together is 36. So plus 36 equals there. Okay? I also want to show you another way to do this. Instead of adding all of these little areas of each of the smaller parts of the larger rectangle, well, how do you find area of a rectangle? Isn't it length times width? So that's another way we can do this. I'm going to put or for this other way, length times width, okay? So length of this is 10 plus x, okay, and we multiply by the width. The width here is 12. See, I got 12, 10 plus 2 is 12. The reason I couldn't go 10x is because those are not like terms, okay? So we just gotta go length times width, and they're saying that the area is 156. Okay, so you see right here, it's this quantity, those are together, times 12. So what I'm gonna do is I'm gonna kind of rewrite this so it's more straightforward that you need to use a distributive property, because you know you have a multiply sign right there. I can just smush that right there next to it, but I want to rewrite it to where put the 12 first and then we multiply it by the 10 plus x. This is the same as this, okay? They're the same thing. See how it's rewritten? It's times 12. This quantity times 12, this quantity times 12, same thing. Okay, you got a number outside the parentheses. 12 times 10 is 120. 12 times a positive x is a positive 12x. That equals 156. So let's go ahead and build it. We start with x, then we multiplied it by a positive 12, then we added 120 to it, okay? From there, inverse operations it. Minus 120, minus 120. Okay, 120 minus 120 is 0. 156 minus 120 is 36. Bring down your equal sign, bring down your positive 12x. Go back up, divide by 12. Do that to both sides of the equal sign. 12 divided by 12 is 1. 1 times x is 1x or x. 36 divided by 12 is 3. See how we get the same answer? So I just wanted to tack that on at the very end just to show you, you don't have to do it exactly the way I did it. If you thought of this more, and this is more straightforward to you, do it that way, okay? Because bottom line is you know how to find area. So use what you know, and if they give you information like this, set up your equation equal to that. If they're saying, hey, area is this, set up your stuff to equal what the area is. Use your area formula, okay? Or you know that area is the combination of all the areas of these little guys added together for the bigger shape, okay? Use what you know. You've got the skills.